we have different test tubes for different concentrations of your amino acid. So let's say this is 0.2. You take 0.2 mil of your known amino acid, leucine in this case, 5 milligram per mil. So in tube 2, you take 0.4. In tube 3, you take 0.6. Tube 4, 0.8. And then in tube 5, we have 1.0. So if we take, this is our acid, these are leucine, amino acid. Leucine, and it's 5 milligram per mil. So what will be the amount of water we're going to put in the first tube? We'll put 0.8 mil to make it up to 1. We put 0.6 here. We put 0.4 here. We put 0.2 here. And then here, there will be no need to put water because it's already 1. So we see that we make each tube to 1 mil. And this is what we call serial. We make each tube up to 1 mil. And then this is what we call serial dilution in biochemistry. And then, of course, we have another tube, which is the tube of the unknown that you have been asked to estimate the amount or the concentration of the amino acid. So this will serve as our unknown, which is tube 6. So this is tube 1, tube 2, tube 3, tube 4, tube 5, then tube 6 for the unknown. And then we just take 1 mil for our unknown. So we can say for the unknown, we just take 1 mil for the unknown. And then when we have done this, we can then put in what we call our neandraine, buffered neandraine reagent. It's a reagent that can be used to estimate the amount of amino acids in a sample, and that is because it forms a complex with the amino acid. And the complex can easily be observed because it's a colored complex. Usually it is purple. I'm going to show you a colored purple complex. So you can easily see it. So you just put 2 mil of this in each of the tubes. Put 2 mils in each tube, including the one for the unknown. When you have done that, you boil for 10 minutes. And when you've boiled, then you can then take all the tubes to the spectrophotometer for absorbance reading. I'm going to give you some readings from what I have done in the lab, and then you can then use this to plot your own graph. So this is absorbance for tube 1 from what I've done. For tube 1, I have 0.075. For tube 2, I have 0.177. For tube 3, I have 0.225. The next one, 0.30. That's at tube 5. And then for tube 1, 0.075, tube 2, 0.177, tube 3, 0.225, tube 8, 0.30, then tube 1 is 0.375, and then our unknown is 0.240. So making use of these values, we can easily plot a graph. Our absorbance versus concentration graph. And remember that we have said we make use of the Beer-Lambert's principle, which makes us understand that the relation between absorbance and the concentration is linear. So we get the absorbance reading, making use of this spectrophotometer, and then we try to plot the absorbance versus the concentration curve. Then our curve must always begin from the origin. The origin is 0. We make sure that our curve begins from the origin. And when we have done that, we can be able to plot a straight line graph, making use of the values that we have here for our absorbance and the concentration. But let me quickly talk about the concentration, because these are the values that we have already. We need to get the concentration values for each tube. Now, for our tube 1, we took 0.2 ml of our amino acid. So we can use a formula that we call dilution formula. C1V1 equals to C2V2. So where your Z1 is the concentration, the initial concentration of your amino acid, then the V1 is the volume that was taken from your amino acid. So that is concentration. Initial concentration now. Initial concentration of your amino acid. And of course, we saw that the initial concentration is 5 milligram per mil. Then the V1 is the volume that you will take. The volume that you're going to take from the amino acid. So volume of amino acid taken. Then your C1, C2 is the one that we don't know. So we can call it X. It's our unknown. Our V2 is the final volume in each tube. So now our concentration is 5 milligram per mil. Then we multiply it by the volume that we take for tube 1. The volume will be 0.2. And then the concentration is what we don't know. Then the final volume is 1. The final volume that we make each of the tube 2 is 1. Then when we multiply this together, we say 5 times 0.2. I think that one we should give us 1. That should give us 1.0. So this should give us 1.0. That means our C2 for tube 1 is 1.0. So what's going to be as our C2 for tube 2? So for tube 2, we can just say 5 milligram times the volume that we took from the amino acid, that's 0.4. So it will give me my C2 for tube 2. And that is going to give me 2. So that means in tube 2, my concentration is 2 milligram per mil. Then if we go to tube 3, in tube 3, it's going to be 5 milligram times 0.6. And then our answer should be 3. Answer should be 3. That is 3 milligram per mil. And then in tube 4, what are we going to have? Please permit me to use this place. Tube 4, that will be 5 milligram per mil times 0.8. And then what we have finally is 4 milligram per mil. Then in tube 5, it's going to be 5 milligram per mil multiplied by 1. So what's going to be our concentration in that place? That's going to be 5 milligram per mil. You remember that is what we started with. So when you just take 1 mil of the original sample, you are still dealing with the original sample. So when we have done that, we know that we have all the concentrations in each tube. So you come here, you write your concentration the concentration in each tube. Concentration in each tube. In tube 1 is going to be 1.0. In tube 2, that's 2.0. Tube 3, 3.0, 4.0, 5.0 in tube 5. Then we are left with the unknown, which we are to solve for. Now, if we know the absorbance of the unknown, it's possible for us to get the concentration. So when we take the absorbance reading of our unknown, let's say the absorbance is somewhere here. Yes, okay. So now when we have taken the absorbance reading of the amino acid, we get a straight line graph, so we can then make it straight. That's a straight line, a straight line. When we get a straight line, we can now take the value of the absorbance reading for the unknown. Let's say the absorbance reading is somewhere around this place. We can take the absorbance reading and then extrapolate, that is, trace it down to the concentration axis. Trace it down to the concentration axis. So this is the known absorbance. The known absorbance can give us the concentration that we don't know. So when you get the absorbance for the unknown, you trace it to the straight line graph, and then down it comes. This will give you the concentration of the unknown. Now it will no longer be unknown, it will now be specific. That means you now have a specific concentration for your unknown. And that is how we can be able to get the concentration for our unknown sample, or the concentration of amino acid present in our unknown sample. Thank you very much, and stay blessed. Thank you.